Alright, so this last video is to solve for the pH after the addition of 31 milliliters of HCl. So this is part 4. And in this case, it's a little bit different of a problem. We, again, are going to start by thinking what is going to be in solution and do our limiting reactants for stoichiometry, work first. So this is our quote-unquote reaction that goes to completion, right? So this is going to go to completion. And in this case, the NH3 becomes a limiting reagent. We've gone past the equivalence point. We've added some additional excess H+. So at the end of this reaction, I'm going to have 0 NH3. I'm going to have .0006 moles of H+, that's remaining in the solution, so 0.0031 minus 0.0025. And I'm going to have 0.0025 moles of NH4+ in my solution. So now I've got sort of this NH4+ and H+ thing going on where both of these are acids, right? They're going to be contributing H+ to the solution. But in this case, because I have excess strong acid, right? This would be excess strong acid. The pH of this solution is really just going to be dependent on this excess strong acid because this is so much more, this is going to be so much more concentrated than any small amount of H+, that NH4+ would give it to the solution, that really all I need to do is figure out what the molarity of this H+ is and use that to solve for my pH. So this is a special situation that because I have excess strong acid, and to find my molarity, right, so the next question is what's my molarity of H+? That's going to be equal to 0.0006 moles over my total volume. And in this case, my total volume is going to be 56 milliliters. So I got 56 milliliters simply by adding 25, which was my initial volume for NH3, plus 31 milliliters of HCl that we've added. This gives me my concentration of H+ as 1.07 times 10 to the minus 2 molar. And this is going to be really all I'm going to use for my H+, to solve for my pH. So if I solve the pH here, pH is going to equal 1.97. And that's it.